Hi, my name is Alexandre Siqueira, and I'm a postdoc at the University of Florida. I'm glad to present this work titled PPCards toward enhancing electronic prototyping with additions of a card-based platform. Making, the process of creating something, has become a movement tied to encouraging growth in science, technology, engineering, math, and more broadly arts. There are approximately 135 million makers in the United States alone. Improvements in the making process can benefit a large number of people all around the world. An important part of making is prototyping electronic circuits to create interactive experiences of sensing and controlling the physical world. However, current prototyping platforms have several limitations and trade-offs. We looked at 3 electronic prototyping paradigms to map their weaknesses and strengths: the breadboard and web-based tutorial, virtual prototyping platforms in which prototyping is simulated via software, and hybrid prototyping platforms, which combine active breadboards connected to computers that can display information and measurements about the circuits. Some platforms, such as the breadboard plus web-based tutorial and hybrid ones, allow tangible interaction with physical electronic components. Others require users to split their attention between 2 or more sources of information, which can lead to split attention effects. Split attention effects negatively impact performance by hindering learning, increasing cognitive load, and often promoting longer task completion times. Some platforms provide active feedback to users, while others, such as the breadboard plus web-based tutorial, do not. In this research, we aimed at creating an electronic prototyping platform that would provide users with the following capabilities: tangible interaction with components, and split attention-free approach, and active feedback. Based on prior work, we hypothesized that a platform with these characteristics would improve usability, improve user experience, and reduce the time to complete tasks, which is associated with systems that present reduced or absence of split attention effects. To that end, we developed PPCards, a card-based platform that facilitates electronic prototyping. PPCards is composed of 28 color-coded paper cards, which are the size of regular postcards. With the cards, users can learn about concepts, components, and how to create circuit prototypes. There are different types of cards, such as concepts cards, components cards, project cards, and circuit cards. The PPCards platform adopts a templated approach to prototyping. Circuit cards have illustrations with templates of circuits that guide users creating their prototypes. Users create circuits by inserting components through circuit cards and into breadboards attached to them. There are 3 editions of PPCards, each with increased capabilities. The first edition allows tangible interaction with components with a split attention-free approach. The second edition incorporates multimedia content with the use of a smartphone to display videos. The third edition proposes a projected augmented reality approach, providing users with active feedback while maintaining the capabilities of the other 2 editions. Let's take a closer look at each edition. With the first edition of PPCards, users prototype by inserting electronic components into circuit cards. Cards provide a single source of information for prototyping. This approach mitigates split attention effects. Circuits are completed faster when compared to the web-based approach. The second edition adds links to multimedia content. A special purpose dock holds cards and smartphones. Tutorial videos can be watched in vertical or horizontal orientation. The third edition adopts a projected augmented reality approach. Cards and components are recognized with computer vision. It presents a scaffolded step-by-step approach to prototyping. And provides dynamic, active feedback to users' actions. Such as warnings during circuit assembly. We conducted a user study to compare the first edition of the PPCards platform with the breadboard plus web-based tutorial paradigm. We also conducted a focus group to obtain impressions and observations about all three editions. For the Between Subjects user study, we recruited 19 participants, 9 in the breadboard plus web-based tutorial and 10 in the PPCards condition. Each participant was mailed a package with all the components needed to complete their trials. After receiving the components, participants met with a researcher, signed the consent form, received the initial explanations, and were asked to explore their assigned platform for 5 minutes. Next, they completed a practice project and the second project from which measurements were taken. The first project consisted of creating a circuit that made an LED turn on with the touch of a button. The second was more complex, with more components and made an LED blink automatically when assembled. Given the novelty of our platform design, we were interested in comparing it against a more conventional approach on the scores of usability, user experience, and the ability of the platform to address split attention effects. To a lesser extent, we were also interested in measuring learning outcomes. A t-test analysis was performed on the mean time to complete the task with each platform. There was a statistically significant difference in the mean time to complete between the two conditions. It took participants in the PPCards condition significantly less time to complete the task, confirming our hypothesis and suggesting that we were successful in reducing split attention effects. We applied the user experience questionnaire to measure user experience. A two-way t-test analysis showed that attractiveness, perspicuity, and novelty scores were significantly higher for the PPCards condition, as demonstrated in the figure to the left. We also compared the user experience questionnaire scores from the PPCards condition to a benchmark dataset containing data from over 20,000 people across 452 studies concerning different products. This allows for the relative assessment of the quality of our platform against other products. As shown in the figure to the right, PPCards ranked good or excellent on all 6 scales. We applied the system usability scores to measure usability. We hypothesized that there would be a significant difference between the scores in the two conditions. The results of our t-test revealed that, on average, participants in the PPCards condition reported a significantly higher level of usability than participants in the other condition, confirming our hypothesis. To begin assessing learning outcomes, we asked participants to describe with their own words what the circuit of the second project did, how many components there were in the circuit, and to name as many components as they could. We did not find significant differences between conditions. We hypothesize this is due to ceiling effects and hope to further explore learning outcomes as part of future work efforts. We were also interested in obtaining users' insights and opinions about PPCards as a platform, looking to understand if our proposed second and third editions would be well received. To that end, we conducted a remote focus group via Zoom, and all the participants of the user study were invited to participate in the focus group session. In the end, 6 participants chose to attend, 3 from the PPCards group and 3 from the breadboard plus web-based tutorial group. These are some comments and observations participants made during the focus group. Participants observed that the templated nature of the platform seemed to be better suited for novice learners. One of the participants mentioned the templated system may be better for novice users or learners. Some participants suggested some design improvements. One participant mentioned, "I could see myself accidentally dropping the cards or getting them mixed up, and that would be a mess." participants also made observations that demonstrated their level of excitement about the platform. One of the participants mentioned, "The quick wins made me excited about learning more." Regarding the third edition, another participant mentioned, "It reminded me of science fiction, and it made me want to use it." These observations helped us understand and work toward enhancements that will be further evaluated in user studies in the future. The PPCards platform presented in this work addresses challenges and limitations associated with the use of current resources for learning electronic prototyping. One such challenge is split attention, an effect by which learners are required to divide their attention between at least two sources of information. We also aimed at developing a platform that would allow tangible interaction with components. Results from our user study evaluating the first edition of PPCards demonstrated the platform's potential to address split attention effects, while also scoring high on aspects of usability and user experience. This indicates that the templated card-based approach of the platform was well received. In the remote focus group conducted, we began to evaluate editions 2 and 3 of the platform, and we obtained valuable suggestions for improvements to our future designs. In our future endeavors, we aim to evaluate aspects related to cognitive load and further evaluate learning outcomes with PPCards by developing more complex prototyping tasks, besides ones that more broadly evaluate users' learning. On top of this, we wish to deploy all 3 editions of the platform in classrooms to gain further insights from instructors and students to improve the overall design of all 3 editions. This is all for the presentation. If you have any questions, please feel free to send us an email. Thank you so much for your attention.